Welcome back. Chapter 2 Derivatives, Section 2.5 The Chain Rule. This is a bit tricky, but it takes, with enough practice, it will be okay. Suppose you are asked to differentiate the function capital Fx equals square root of x squared plus 1. The differentiation formulas you learned in the previous sections of this chapter do not enable you to find the derivative. Observe that f is a composite function. In fact, let one of the functions be square root. F of u equals square root u. And let u, that is the object inside, be the other function, gx, x squared plus 1. Then you can write y equals capital F of x, which is composition of f with g. Outside f being the square root, inside g being x squared plus 1. Alright, we know how to differentiate both f and g, so it would be useful to have a rule that tells us how to find the derivative of capital F, which is the composition. So let's see. It turns out that the derivative of the composite function f of g is the product of the derivatives of f and g. So product. This fact is one of the most important of the differentiation rules and is called the chain rule. So here you have a chain. How do you find its derivative? You have to take product of the derivatives. Product. So now, mind you, one has to be a bit careful. It seems plausible if we interpret derivatives as rates of change. What is a derivative? It is rate of change. Du dx means rate of change of u with respect to x. So that entire phrase is written du dx. It's not dd cancel u over x. No. This is a short form of the phrase the rate of change of u with respect to x. Likewise, dy du is now the rate of change of y with respect to u. Likewise, dy dx, rate of change of y with respect to x. If u changes twice as fast as x and y changes 3 times as fast as u, then it seems reasonable that y changes 6 times as fast as x. Okay? In other words, this is something reasonable to expect. Dy dx, the rate of change of y with respect to x must be equal rate of change of y with respect to u times rate of change of u with respect to x. Now, that's the chain rule. So if capital F is little f composed g, right, then the derivative is f prime, that is the outer function, his derivative with gx inside as it is, times g prime. So that's the product of the derivatives. Okay. The only thing to notice, the outside function, his derivative, has the inner function as it is. So this is Newton's law, and this theorem, the chain rule, holds when g is differentiable at x and f is differentiable at gx. Okay. Now dy dx, so in Leibniz notation, dy dx is dy du times du dx. Now, the chain rule, in other words, can be written in terms of prime notation, like this. That's the Newton notation, or the Leibniz notation, like this. Okay. This is easier to remember because it seems like du's can be cancelled. Well, that has no meaning, but I hope the meaning is clear, but it's easier to remember. Now, go back to our question. Capital Fx is square root x squared plus 1. Alright, we expressed capital F as little f composed g, that is f of gx, where f is, little f is the square root function and little g is the polynomial function. Now, little f of u is square root of u, so its derivative is 1 over 2 u to the negative half. Resolving that, you get 1 over 2 square root u in the bottom, whereas derivative of g is 2x. So, derivative of f is outer function, that is little f, his derivative with g inside. That's what I mean. So that u is x squared plus 1 as it is times derivative of g. All right. The 2's cancel. You're left with x over square root x squared plus 1. So in Leibniz's notation, think of u as x squared plus 1. Y is square root of u. Correct? So f prime x is dy du, du dx. Derivative of y with respect to u is 1 over 2 root u. Derivative of u with respect to x, it is 2x. Don't forget, my question had x to begin with. So replace the u by the expression in x. And 2's cancel, and that's that. This is probably a better way of remembering. Okay. So when using formula 3, we must bear in mind that dy dx refers to derivative of y when y is considered as a function of x. Derivative of y with respect to x. Dy du refers to the derivative of y when considered as a function of u. That is derivative of y with respect to u. Okay. Y may be considered a function of x like this. Y also could be a function of u like this. Okay. So derivative of y with respect to x is this quantity, the final answer, whereas derivative of y with respect to u is simply this. All right. So in general, all right, let's come to this page in the next video.